Alright, so after understanding what function notation is, after looking at the lesson right above this section, what we're going to do now is we are going to evaluate the function by plugging in the x value for each of these examples into the function above. So starting off here with the letter A, right, we're going to start with the first part of this question. We're going to find the value of f of negative 2. So x in this case is negative 2. Right, so what is in parentheses? The parentheses is negative 2. That's my x. So when x is negative 2, what we do is we plug that into our formula, our function here. So like our input-output table, we take the negative 2 for x, and we substitute it for the x in our function. Okay, so after we plug in the x into the function, what we're going to do is now we're going to evaluate or solve this. So we start off with our multiplication, because multiplication comes first in PEMDAS. That's 2 times negative 2, which is negative 4. And then we have negative 4 minus a 3. And again, when you have a minus sign here, what you can do is you can change that to a positive, and our 3 becomes a negative. And now we're simply just adding two negatives together to give us a negative 7. Okay, for number 2, same idea. Since 7 is in parentheses, that represents our x here, so x is equal to 7. Now we're going to plug that 7 into our function. That's this right here, 2x minus 3. So we take the 2, we multiply it by 7 inside the parentheses, and then lastly we subtract it by 3. When you do out the math, 2 times 7 is 14. 14 minus 3 is 11. Okay, and for the last part here, what we're going to do is do the same idea, right? X is equal to negative 4. We're going to plug that into our function, 2 times the negative 4, close parentheses, and then subtract it by 3 after that. So 2 times negative 4 will give you negative 8, and then negative 8 minus 3. Again, you can change the sign to a positive. Once you do that, the 3 becomes a negative, and then we just add them together. And when you add negative 8 and negative 3 together, you get a negative 11. Alright, sometimes there will also be multiple x's in the equation. When this happens, you simply will replace both values or all of your x's for the x that you have in your problem. So if you look at number or letter A here, now we have x is negative 3. Where do we see x's in our function? I see an x here, and I also see an x here. So I'm going to take that negative 3, and I'm going to plug it in for all of the x's here. Okay, so starting with the negative 3 to the second power, minus 3 in parentheses, my x is negative 3, plus 5. So again, I'm going to highlight what I just did, right? So I took the negative 3, plugged it in for x, that's this right here, negative 3. I also plugged it in inside the parentheses, that's this negative 3. And now we're just going to simply evaluate or solve this. So negative 3 to the second power is negative 3 times negative 3, which is 9. Negative 3 times negative 3, multiply those together. 2 negatives give you a positive. That's positive 9. And then add 5. So now we're just adding across, right? 9 plus 9 is 18. 18 plus 5 is 23. So when my input is negative 3 here, my output is 23. Same idea for the second part, right? Now instead of us plugging in the negative 3 for the x, our problem says that the x is actually 5. So take this, h of x, h of 5, and plug in 5 into all of the x's in the function. That's 5 to the second power minus 3 times 5, and then add 5 at the end. 5 to the second power is going to give you 25 because 5 times 5 is 25. Negative 3 times a 5 here is going to give you negative 15. And then lastly, just add on that plus 5. And then when you do out the math here, 25 minus 15 is going to give you 10, and then 10 plus 5 is 15. So my answer here would be 15. All right, so now I want you guys to try the these next few problems, and then at the end there's going to be some classwork for you to complete during class time today.